You're walking barefoot. You step on a Lego, and in 0.1 seconds, your entire nervous system goes to war. But here's the thing. That moment of agony? That's not your body failing you. That's your body saving you. Pain is the most misunderstood signal in human biology. We spend billions of dollars every year trying to eliminate it, but most of us have never stopped to ask, why do we have it in the first place? Today, we're going to break down every major type of pain, where it comes from, why it feels different, and why sometimes your brain invents pain that has absolutely no physical cause. And it's completely real. This is pain. Simply explained, let's start at the beginning. Your body has specialized nerve endings called nociceptors, from the Latin nocere, meaning to harm. Think of them as microscopic alarm sensors buried in your skin, muscles, joints, and organs. They don't fire randomly. They only activate when something crosses a damage threshold, extreme heat, pressure, chemicals released by injured tissue. When they fire, the signal travels up your spinal cord like an electrical telegram, straight to your brain's thalamus, which acts like a relay station. From there, it fans out to two key areas. The somatosensory cortex, which tells you where it hurts. The limbic system, which tells you how much you care. And that second part? That's why pain is never purely physical. It's always emotional too. Here's the evolutionary genius of this system. Animals that felt pain survived. Animals that didn't? They kept using broken limbs, ignoring infections, touching fire. They didn't make it. Pain is not your enemy. Pain is your oldest survival tool. But like any system, it can malfunction. And that's where things get fascinating. The most common category of pain is called nociceptive pain, and it comes in two very different flavors. This is the pain you know best. You stub your toe. You pull a muscle. You sprain your ankle. That sharp, immediate, very locatable sensation, that's somatic pain. It comes from nociceptors in your skin, muscles, tendons, and joints. And the reason it's so precise is simple. Your brain has spent your entire life mapping your body's surface. It knows exactly where everything is. There are two speeds of somatic pain. Fast pain, carried by A delta nerve fibers, arrives in milliseconds. Sharp, stabbing. Something just happened right here. Slow pain, carried by C fibers, follows seconds later. Dull, throbbing, aching. This is the one that lingers. Next time you injure yourself, notice both waves. The sharp, ouch, then the deep throb that follows. That's two completely different nerve pathways talking to your brain. Now here's where it gets strange. Your internal organs, your stomach, intestines, liver, kidneys, also have nociceptors, but they're wired completely differently. Visceral pain is vague, diffuse, hard to locate. You feel it as a deep pressure, cramping, or squeezing, and you often can't point to exactly where it is. Why? Because your brain never had to precisely map your organs. Evolutionarily, you never needed to know your liver was 4 inches to the right. So the wiring is crude, fewer nerve fibers, less precise maps. But here's the most mind-bending part. Referred pain. When your heart is in distress, a heart attack, many people don't feel chest pain at all. They feel pain in their left arm, jaw, or shoulder. Why? Because the nerve fibers from your heart enter the spinal cord at the same level as the nerves from your arm. Your brain gets confused. It's been processing arm pain your whole life, so that's what it assumes. It misreads the signal. This is why visceral pain is medically dangerous. Your body is literally pointing in the wrong direction. So far, the pain signals we've talked about are accurate. Tissue is damaged, alarm fires, brain responds. But what happens when the alarm system itself breaks? That's neuropathic pain, and it's arguably the cruelest category. This occurs when nerves are directly damaged or dysfunctional. Not the thing the nerves are sensing, the nerves themselves. Sciatica. The sciatic nerve is the longest nerve in your body, running from your lower spine all the way down to your toes. When a spinal disc bulges and presses on it, you don't just feel back pain. You feel burning, shooting, electric shock pain traveling down your entire leg, into your calf, your foot, your toes. The nerve is being compressed, and it's screaming the entire length of its pathway. Diabetic neuropathy. In poorly controlled diabetes, chronically high blood sugar gradually destroys peripheral nerve fibers, starting with the longest ones first. That's why diabetics often feel burning and tingling in their feet before anywhere else. The nerves don't just go quiet when damaged. They misfire. They send pain signals when there's no injury. They fire spontaneously at 3 a.m. They interpret a bed sheet touching your foot as searing pain. This is the key difference with neuropathic pain. It doesn't mean something is damaged at the site of pain. It means the information highway is broken. The message is corrupted somewhere between the source and the brain. And unlike nociceptive pain, it often doesn't respond to normal painkillers, because there's nothing to block at the tissue level. The error is in the wiring itself. Here's where things get genuinely philosophical. What if I told you your brain can generate completely real, completely debilitating pain with zero physical cause? Acute pain? Listen to it. It's telling you something is wrong and needs attention. Chronic pain? The signal has gotten stuck. The alarm is ringing even when the fire is out. That's not weakness. That's a neurological pattern that needs to be addressed, often with a combination of medicine, movement, psychology, and time. The most important shift in modern pain science is this. Pain is not a measure of damage. You can have massive tissue damage and feel nothing. Soldiers in combat report this constantly. And you can have zero detectable damage and be in agony. Pain is your brain's best guess at what's happening, filtered through your emotions, your memories, your stress levels, your expectations. Understanding that doesn't make pain disappear, but it changes your relationship with it. Because when you understand the signal, you stop fearing it. And fear, as it turns out, is one of the most powerful amplifiers of pain that exists. Your body isn't broken. It's talking. Maybe it's time we learn to listen better. If this video helped you understand pain differently, share it with someone who needs to hear it. And if you've been living with chronic pain, know that the science is catching up. And so are the treatments. See you in the next one.